The sum of any two terms is called a binomial. Here we have x plus y is a binomial. What we're going to do in this lesson is we're going to see what happens when we raise binomials to different powers and multiply everything out. So that's what we're going to do. We're going to multiply each one of these all the way out and get a whole expansion. And what we're going to do is we're going to look and see if there's a pattern in what happens, a pattern in the results when we expand these. Now, of course there's a pattern. I wouldn't just ask you to do this just for busy work, because boy, that doesn't really look like a whole lot of fun. And that's the whole point of doing this. We're going to do this once, see if we can find a pattern, so in the future, when we have to raise binomials to powers, we don't have to multiply everything out. So let's see, we'll start up here with x plus y to the 0. Not a trick question. Any non-zero number raised to the 0 power is just 1, so x plus y to the 0 is 1. And the next one, x plus y to the first power, again, not a trick question, it's just x plus y, which I'll write as 1x plus 1y. What I'm going to do here is I'm going to write these numbers, the coefficients here, I'm going to write these in blue. And we are going to look for a pattern in these numbers. So that's just 1x plus 1y. Now x plus y squared, not as simple as these two. We can go ahead and multiply that out, because x plus y squared is just x plus y times x plus y. And we can use the distributive property here. This equals x times this plus y times this. And if you already know what this is going to come out to be, you can move on to x plus y cubed, x plus y to the 4th, while we multiply this out. X times x is x squared, x times y is xy, and then over here y times x is xy again, y times y is y squared. And now we see what this comes out to be when we multiply it all out. We have the 1x squared term, so we have the 1x squared. Then we can combine these two, and that gives us 2xy, and then we have the 1y squared term out here. See the pattern yet? No reason you should. We haven't really done a whole lot yet. Well, now we're going to move on to x plus y cubed. Go ahead and erase x plus y squared. And we don't have to start from scratch here, because we already have x plus y squared. So we can write x plus y cubed is just x plus y times x plus y squared. So we get to use this to get x plus y cubed. Since we already know what this is, we can write this as x plus y times x squared plus 2xy plus y squared. And we can multiply this out. And again, we're just going to use the distributive property here, nothing magic. This product is just x times all of this plus y times all of this. And we'll go ahead and write it out. And writing out all these little steps seems a little tedious, but it sure helps us prevent making mistakes. Okay, now we can multiply this out. X times x squared is x cubed. X times 2xy, 2x squared y. Then we have xy squared. Now we just multiply y times each of these terms. And there we go, we have our expansion. We can combine some terms here. First we see there's only one x cubed, so go ahead and write that down. 1 x cubed plus, and go ahead and scratch that out. Let's see, we have an x squared y here, and then another one over here. So 2x squared y plus x squared y, that gives us 3 x squared y. Alright, so we can scratch those out. Then we go into xy squared. 1xy squared plus 2xy squared. 1 and 2 is 3. Now you're starting to see the pattern? And then there's just the 1y cubed term out here. Recognize these numbers. Alright, take a guess. What's x plus y to the 4th? Write it down, and then we're going to multiply it out. And we will see how good your guessing powers are. Got your guess? Got it written down? Alright, now we're going to multiply it out. We're going to race. You ready to go? Alright, here we go. We're going to race. Ready? Set. Go. Okay, x plus y to the 4th. X plus y to the 4th. X plus y to the 4th is x plus y times x plus y cubed. So I can just use this up here. X plus y. We know that x plus y cubed is this up here. You ahead of me? Come on, faster, faster. You should be beating me because I'm having to talk while I'm writing. You finished yet? Finished? Okay, we're going to take this product. That's going to be x times all this plus y times all this. Oh boy, I'll bet you're ahead of me, aren't you? Did you get what you guessed? Did you get what you guessed? Oh, you can just move on to x plus y to the 5th if you're that much faster than me. This does take a long time, doesn't it? Sure would be nice to have a formula that would prevent us from having to do all this algebra. Wouldn't it be nice to have a formula? Okay, now I got x times all this plus y times all this. Well, now we multiply all this out. I'll bet you were finished a long time ago. Yeah, this really does take forever. I want a formula. Wouldn't you like to have a formula to do this so you wouldn't have to write all this? And my hand's getting tired. Multiplying y by each term in here. You know, y times x cubed is x cubed y. Y times 3x squared y squared is 3x squared y gives us 3x squared y squared. And this is taking a long time. Look at that. That doesn't look like a whole lot of fun. But we have multiplied it all out. Took us a while. But now we know what x plus y to the 4th is. We've got the x to the 4th term. Let's go ahead and write that down. 1 x to the 4th. And cross that off. Let's see, we got x cubed y here, 3x cubed y plus 1x cubed y. That gives us 1 plus 3 is 4. 4 x cubed y. Whew. Cross those off. Now we get the x squared. We got 3x squared y squared, another 3x squared y squared. So that'll be 6. 3 and 3 is 6. 6x squared y squared. And let's go ahead and cross these off. xy cubed plus 3xy cubed, 4xy cubed. And I bet you guys are really excited to go into x plus y to the 5th. Then there's just the 1, after we cross these off, all that's left is the 1 y to the 4th. Now do you recognize these numbers? Look at the blue numbers. Kind of relax your eyes, forget about the x's and y's for a minute, just look at the coefficients. These coefficients are Pascal's triangle. In other words, these coefficients are all combinations. I wonder why that's true. Maybe it's just a coincidence. So here's what you're going to do. You're going to go ahead, I want you to do one more on your own. Gut it out. Do x plus y to the 5th. Before you do it, first guess what the coefficients, guess what the outcome's going to be. Write it down. Write down your guess so you can check it. And then multiply it out. Do all this, nasty, multiply it all. You'll get a bunch of terms down here that you can add up and combine and see if your guess is right. and see if these numbers just keep on going. X plus y to the fifth is the next row of Pascal's triangle, the next row of Pascal's triangle. And once you're convinced, if you're convinced, that you'll always be getting rows of Pascal's triangle doing this, you know what the next step is. Figure out what's going on here. Why does this happen?